Hello, so I'm back again, and I think I'll release a third video going into a little bit of detail on the corners I cut. But here, I'll pick up where I left off, and the last video and the first part of this one are a bit of a statistical mechanics build up, sort of the general formalism, which will then narrow down to the specific ideal gas system. It serves as a really good example of all this stuff. So far, the corners cut depend on a lot on one's mathematical background, and but particularly my definition of temperature is 1 over temperature being the derivative of the entropy with respect to energy was big corner cut. Assumption made. So to continue where I left off, at the top, there's a bit of a review. The final expression we got for the number of states of the system at E total rounds to sort of exponential of the entropy times the sum over all the energy levels. And the number of states in level n is just a term of that sum because the contribution per term in E total is just the number of states at that energy level. So to get the probability, you just divide the two. And that's called the Boltzmann distribution. There's a lot of different uses of the term distribution in math and physics. And one is that sort of distributions are sort of terms for the general sort of probability functions. Is one of the big uses of that term. And no surprise, Boltzmann was the one to discover this particular distribution. So the denominator of the distribution is an extremely important feature of a system called the partition function. And the expression for it in notational label for it is at the bottom. Is typically use a z to denote it.